Hello everyone, myself A.Yadagiri, Assistant Professor, Department of Electrical and Electronic Engineering, MLR Institute of Technology, Hyderabad, and also I am the Faculty of Basic Electrical Engineering. In the last session, we have discussed about the analysis of the pure resistor network with the AC source. So in that we have discussed about the what is the instantaneous voltage, what is the instantaneous current, and what is the instantaneous power, and also the phase angle between the voltage and current, and also the power factor of the pure resistor network. So these so many things we have discussed in the last session. So in this session, we are going to discuss about the analysis of the pure inductive network with the help of alternating source or AC source. So the overview of the session means, in this session, we are going to dealing about the instantaneous voltage of the inductor. I mean, how we are going to get the instantaneous voltage of the inductor, and based on that, how much amount of alternating current in terms of instantaneous going to the inductor coil. So based on that, how much amount of back EMF production is happened. So after that, how much amount of instantaneous power taken by the inductor. Then based on that, how much average power consumed by the pure inductor. So then based on that, we need to draw the phasor representation of the inductor with the help of voltage and current. So then after that, how much amount of power factor is going to take in place between the voltage and current. So these so many things we need to discuss about in this session. So let's begin the session. Let us consider inductor. So having the L Henry. So we need to connect to one alternative source to the inductor. So which drives an alternating current, that is in terms of the instantaneous nature, that is small I. So every instantaneous parameter we need to represent with the small letters. So based on that one, so we need to consider inductor and which supplied from which is connected from a instantaneous voltage source. So let us apply the instantaneous voltage to the inductor. So that is V equal to then Vm sin omega t or sin theta we need to apply. So based on this one, some amount of alternating current is circulating into the inductor coil. So that instantaneous current to develop the some amount of electromotive force in this coil. So that is we can call it as a back EMF. So due to the applied voltage, as a result, there will be a alternating current or instantaneous current is so flowing towards the inductor coil. So that create the back EMF. So that is E directly proportional to the di by dt. Or also we can say so E directly proportional to the d phi by dt. So both same only. So then we'll get the minus L into di by dt. According to Lenz's law, we will get the minus here. So it is opposing the cause of creation. That's why we'll keep here minus. So this is the back EMF. So the back EMF and also the applied voltage. The back EMF and applied voltage are, I mean to say the instantaneous voltage, applied voltages are equal and opposite. So based on that, V equal to, we can say minus E. So then V equal to, we need to write E value is this one, minus L into di by dt. So this is the applied voltage. So based on some simplification, we will get so V equal to L into then di by dt. So from this one, so these things we will discuss later. Based on the voltage and current, we will get these waveforms. So how much amount of instantaneous current is circulating into the inductor, that we need to try to deriving. So that so instead of this one, so we can so treat as this one is the equation number 1. Then substitute the equation number 1 as instantaneous voltage. So that should be the Vm sin omega t. Vm sin omega t equal to L into di by dt. So we need to write the di value. That means Vm upon L, then sin omega t into dt. So this is the current function we will get in terms of the this nature. I mean the current value we will get in terms of the differentiation nature. So based on this one, we will get. So the current value is, so I'm going to take here, so I mean to say this above expression we need to do some integration. I'm trying to finding out the current value of the inductor. So for that we need to do some integration. So means integrating on both sides. So integrating on both sides. So we will get integral di equal to, so Vm, integral Vm by L into sin omega t into dt we got, into dt. So finally we will get I equal to, so that is a Vm upon L, this is a cos omega t, I mean to say the minus cos omega t So into minus cos omega t. So then divide by, we'll get omega, means the differentiation of the sin omega t is a minus cos omega t. Then we need to do the omega with respect to dt, that will get it as omega. So that the final current expression will be, the current I equal to Vm by omega L, then minus cos of omega t. So this, the current expression we got. This is the expression number 2, we can treat as. So that is the equation number 1. We can consider the equation number 1. So that is V equal to Vm sin omega t. As of now, we got only 2 expressions. So this is one. Earlier, in the earlier case, we have already allotted the equation number 1. This one, same way I am going to write. So that is equation number 1. And the equation number 2, instantaneous current is Vm by omega L, that is a minus cos omega t. So this is the expression number 2. So I am also going to write this one is in terms of sine nature. So that Vm upon omega L, then sine of omega t minus pi by 2. Sine of 90 minus theta, similar to that. So we can write the sine of omega t minus pi by 2 is that minus cos omega t. So based on that one, I equal to Vm upon omega L, that is the sine of omega t plus pi by 2. So the I value, the instantaneous current, the I value, so the I value will be maximum at, the I value will be maximum at sine of omega t minus pi by 2 is unity. So at this time only we will get the whole value will become I max, that is I equal to, then I max equal to, that is a Vm upon omega L. So this value should be 1. So that the whole I will become as a I max. So which means Vm upon omega L. So this is the expression number 3. I am going to treat as. So then, so this above value. So the above value. So we need to substitute in the equation number 3. The above value substitute in equation number 3. So finally we will get I equal to, instead of this omega upon Vm upon omega L is a I max. So that I max into sine of, that is omega t minus pi by 2. So this is a instantaneous current is flowing through the inductor, that is I equal to, means Im or I max into sine of omega t minus pi by 2. So this much amount of alternating current circulating to the inductor coil. So due to the applied voltage, due to the instantaneous voltage, this much amount of current is circulating to the coil. So based on this one, we need to draw the waveform notation. So that is this one only. So this is the instantaneous voltage we have applied to the inductor. So that will drive the resultant instantaneous current as this one. So both are going to maintain some phase displacement. That's called phase angle between these two. So based on this one also, we need to draw the phasor diagram. So need to draw the phasor diagram of the pure inductive case. So further, let us consider the current voltage as reference. So this is a voltage of inductor is a V. So voltage of inductor. Then so the current of the inductor is always lags the voltage at an angle of 90 degrees. So this is the current. So in the inductor, so the current is always lags the voltage at an angle of 90 degrees. So this one also saying us about the voltage and current of the inductor. So here we have considered about the instantaneous values of the peak values of the voltage and current. So it is also same only. So based on the voltage of the inductor, the current is always lags behind that at an angle of 90 degrees. Also we can say in other words, the current of the voltage of the inductor, so with respect to the current, it's always leads ahead that at an angle of 90 degrees. So both are same only. So from the phasor diagram, it is the phasor node presentation or phasor diagram. So from the phasor diagram, see it is clearly. So we can conclude that the voltage always, so voltage leads the current. Voltage always leads the current by an angle of 90 degrees. So if it is a pure inductor, then we will get this much phase displacement between these two. So that is the voltage is always leads ahead the current at an angle of 90 degrees. So this is regarding the phasor diagram. So based on this one, the phase angle should be equal to, that is a phi, we can say the phi equal to the 90 degrees. So based on this one, the power factor of the corresponding system, that is a cos phi, means cos 90 equal to, that is 0. So if you are able to make any kind of load in the nature with the help of pure inductor, the corresponding load power factor should be 0, so that we didn't run the loads based on the requirement, so we cannot make any kind of load with the help of pure inductor. So that's I'm going to conclude. That's I have conclude here. Then after that, we need to find the instantaneous power. So we have also plotted the waveform here, that is the voltage and current. So here also we are going to plot the voltage and current waveforms. So this is the applied voltage. So with reference to the applied voltage, this is the theta or omega t. So this is V, and also we are going to represent the current waveform with the help of other color. So this is the current of the above circuit. So this is the pi, then this is the 2 pi. So this is the pi by 2. So the current is always lags the voltage at an angle of 90 degrees. So this is the corresponding phase angle. So this phase angle phi equal to 90 degrees. So this is about the phasor diagram of the inductor. Then based on this one, we need to find out the instantaneous power. So till now we have discussed about the instantaneous voltage applied to the inductor. Then so based on that one, this much amount of instantaneous current is circulating. So then based on that one, we need to draw the diagram of the the phasor diagram of the inductor. Then after that, so we have also determined about the power factor of the inductor. So then after that, we need to find the instantaneous power. So instantaneous power. So the instantaneous power, it is a product of the instantaneous voltage and current. So from the equation number 194, so we need to find the instantaneous power. So that is a P equal to, so Vm, instantaneous voltage of Vm sin omega t into Im, that is a sine of omega t minus phi by 2. So need to write need to do some simplification here Vm, then Im, sine omega t we can write. So instead of this one, we can write it as a minus cos omega t. Therefore P equal to minus Vm, then Im, sine of omega t into cos omega t. So for this expression, we need to multiply the 2 and also divide the 2. So for that, we will get here minus Vm, then Im times of 2, then 2 of sine of omega t into cos omega t. So it is similar to the trigonometrical function or trigonometrical formula is so sine 2a. So with respect to that, we can write it as here Vm, then Im, so divide by 2. So this one we can write it as a sine of 2 omega t. The sine 2a equal to 2 sine a cos a. Similar to that, so we can write this one is the sine of 2 omega t. So this is the instantaneous power taken by the inductor, that is the minus Vm Im, so sine of 2 omega t. So this much amount of instantaneous power consumed by inductor. So based on this one, need to find out the average power. So the average power over a complete cycle of inductor. The average power taken by the inductor in a complete cycle. So that should be the integral. So 0 to 2 pi means P average equal to, so for one cycle means the span should be 2 pi, so that integration 0 to 2 pi. So there is a minus Vm Im by 2 sine of 2 omega t equal to 0 it is. So why should I say 0 means, so the instantaneous power has the only one part, which is vary with respect to the frequency of this corresponding power with respect to time. I mean to say the instantaneous power has the sine function with a double frequency. So the instantaneous power of the above inductor with the double frequency should become 0. Why? Because it's a sine function. The sine function average value will become 0 based on that one. So the average power taken by the inductor. So similar to this one, this is the average. This is the sinusoidal waveform. So the average value of this one should become 0. So based on this one, the average power taken by the inductor over a complete cycle should be 0 because it has the sine function with the double frequency. So based on that one, the instantaneous power taken by the inductor should become 0. So therefore, P average equal to 0 only. So this is the instantaneous power, the average power taken by the inductor. So based on this one, we need to draw the power and voltage and current waveforms. So this is the voltage waveform. So this is the voltage waveform, that is a blue one. So this one we have already discussed. Then the current is always lags that at an angle of pi by 2 or the 90 degrees. So this span should be, it is a pi by 2 or 90 degrees. So based on this one, we will get the power. Power is we will get the twice in the complete one cycle. I mean to say, in the span of 2 pi we will get the 2 power cycles. So because the instantaneous power, that is a P instantaneous equal to, that is a minus Vm Im by 2, then sine of 2 omega t. So here in the one cycle or in the span of 2 pi we will get the 2 power cycle. So based on that one, so this is the one cycle in the span of pi, and also in the span of other pi we will get the one more cycle. So the average power or the average value of the instantaneous power of the inductor should become 0 in a complete cycle. So this is the power taken by the inductor. So based on this one also, according to the phasor diagram, so this is the applied voltage, the peak value. It's also applied current. I mean to say, it has to run some current, that is a peak value of current. So it has to conclude, the point is the current flowing through the inductor always lags behind the voltage at an angle of 90 degrees. So based on this one, so the average power taken by the inductor over a complete cycle should become 0 because it has the sine function with the double frequency. So any parameter, I mean say the voltage or current, so it has with the sine function or cosine function with any kind of frequency, the average value will become 0. Based on that one, the power taken by the inductor should become 0. So this is the power, voltage and the current waveform of the inductor, and also the phasor representation. So the summary of the session, in this session till now we have discussed about the how much instantaneous voltage applied by the inductor, and based on that one, how much amount of resultant instantaneous current is circulated into the inductor. So that instantaneous current develops some amount of back EMF or counter EMF or self-induced EMF. So based on that one, some amount of current flow. So that is a small I. So it is simply we can say that I equal to Vm upon omega L. So sine of omega t minus pi by 2. So this is the instantaneous current we got. So based on this one, we also got the power factor angle or the phase angle. So between the voltage and current, that should be 90 degrees. Then after that also we have determined the average power. The average power over a complete cycle of inductor should become 0 based on why? Because so it has presented with the sine function with the double frequency. That's why the average power taken by the inductor should become 0. And also one term missing in the session, in this one, that is so this one we have so missed, that is a Vm by this term. So this term we have missed that. So here Vm, that is I value equal to the in the current equation, I value equal to the is Im by omega L. So Im is the peak value of current. Then omega L is the it is the inductive reactance. So it is the ohmic property of the inductor which opposes the flow of alternating current. It's called inductive reactance. So this inductive reactance also symbolically represented by the capital XL. It's also called inductive reactance, and it's also measured in terms of the ohms only. According to the Ohm's law, according to the resistance of the material, it also opposes the flow of alternating current, so that it is also measured in terms of the ohms only. The omega L is nothing but it is the inductive reactance of the coil, so which is symbolically represented by the XL, and we can also written this one is 2 pi times of FL. So from this term, to say Imax equal to the it is a Vm by omega L. Imax equal to the Vm by omega L from this term. So from this term, Imax equal to the Vm by omega L. So the same value, so we can write it as omega L as a XL. So which means Vmax upon Imax. So that is here Vmax we need to write it as 1 by root 1 Vm by root 2, then Im by root 2. Simply say we need to So divide and multiply with the root 2 so that we will get this one. Therefore, XL equal to Vrms upon Irms. So the inductive reactance of the any coil should be, it's a ratio of the applied voltage and current. So we need to remember this one, that is XL equal to Vrms upon Irms. So in this instantaneous current, then Vm by omega L, where omega L is the inductive reactance, it's also represented by the XL, means so 2 pi FL. So how can you get the XL value in the numerical, means XL equal to, that is a V by I. I mean to say Vrms into Irms. So then after that we have also draw the phasor representation of the voltage and current. So it is clearly say that the current of the circuit always lags behind the voltage at an angle of 90 degrees. So based on this one, the power cycles of the 2 pi span will get twice, because we got the instantaneous power in terms of the sine of 2 omega t. So based on that, so we got the 2 power cycles in the one complete cycle of the applied voltage or applied power. So based on that one, the average power or instantaneous power taken by the inductor should be the Vm Im by 2 sine of 2 omega t. So based on that one, the average power consumed by the inductor over a complete cycle should become 0. So this is the discussion about the pure inductor. So this is the end of the session. In the next session, we are going to discuss about the analysis of the capacitor with the AC source. So thank you one and all in this session.